Hello viewers, welcome to this video. In this video, we will be looking at the November 2020 Science Paper 2, question B2. Question B2 reads, a learner carried out a chromatography experiment to identify components of substance X. Water was used as a solvent. The results of the experiment are shown in the chromatogram below. A learner carried out a chromatography experiment to identify components of substance X. Water was used as a solvent. The results of the experiments are shown in the chromatogram below. So this is a chromatogram. Now, what is a chromatogram? A chromatogram is the final product, the final paper after chromatography has taken place. So it's the filter paper with all the dots or all the results after the experiment has occurred after performing chromatography. So we have our filter paper there, okay? And what do we have on the filter paper? So we have the substance that is being investigated, and it is substance X. Okay, so we want to find out what okay, so so we just want, then we have those unknown components. So we've got unknown component A, we've got unknown component B, and unknown component C. So we know the identity of the substance X, and we want to see whether any or all of these unknown components can actually be identical to X. So how does chromatography work? Chromatography is based on solubility. Okay, chromatography is a separation technique, okay, used to separate components of a substance with different solubilities. So we need to always understand that chromatography uses solubility to separate various components of a mixture. Now, how does it do that? So depending on how soluble a substance is, that particular substance will move a certain distance from its initial position. So the more soluble a substance is, the further it will move up the chromatogram. Okay, so the more soluble, the longer the distance it covers. The less soluble, the less the distance it will cover. And if a substance is insoluble, that substance will not even move from the initial position. Now, how do we then identify? How do we then identify that these substances are contained in this particular thing? So if two dots, let's take for example, we had another substance here called, let's say Y. So if Y initially was here, and after some time Y moves to that position, okay? If Y was initially there and Y moves to this position, all right? We then look for a dot which is in the same line as Y, okay? So Y has moved from there coming to there, all right? So Y has moved from its initial position coming to there. We now search for another substance which is in the same line. So we just draw a line, and if we find a dot in that line where Y is, then that substance is contained in Y, or that's, yes, it's contained in Y. So Y may form multiple dots. Let's take for example, Y also travels, okay? Y also travels and has another dot that is there. It means that what it will mean is that Y has two different substances that were mixed, because on top of that Y, which is the initial position, Y has produced this dot and also this dot, which means it has one and it has two substances. So then Y will have two substances. Then a question may be asked, okay, what two substances were mixed to form Y? So because substance 2 is in line with B, okay? Substance 2 is in line with B. It means B was used to make Y. And substance C also is in line with the first dot. It means that C was also used to make Y. It means that Y contains substance B and substance C. I hope this will help, even if it has nothing to do with the question here, but I think that may help in the nearby future. So let's now rub everything we've written on the chromatogram. Okay, that was just a quick intro on chromatograph. So chromatography uses solubility, and the higher a substance goes, the more soluble it is. The lesser distance it covers, the less soluble it is. If dots are on the same line, then the substance is contained. All right, so let's now proceed. Okay, let's proceed to the first question. Okay, let's proceed to the first question. The first question is, which one of the unknown components A, B, or C is insoluble? Which of the unknown components A, B, or C is insoluble in water? So insoluble, what did we say about insoluble? Insoluble substances, meaning that they will not even move from the starting point. So an insoluble substance will be that substance which will not even move from its initial position. So what is the substance that has not even moved from its initial position? The substance is substance A. Substance A has still remained on the starting line, while substance B and C have actually moved from the starting line. So substance A is insoluble in water. So we're just going to say substance A. So substance A is insoluble in water. Explain your answer is the next. So A has got two parts. It's identifying the substance which is insoluble and giving an explanation. So the explanation here is that substance A because substance A has not moved from the starting point. So because it has not moved from the starting point. All right. So there we have for A. So if it was soluble, it would have moved. All right. So substance A and substance C. And the reason is that it's insoluble because it has not moved from the starting point. All right. Then we go to B. Which of the unknown components was or were not contained in substance X? Which of the unknown components was or were not contained in substance X? So it means that we are looking for a substance whose dot does not fall in the same line as any dots in X. So what we're going to do is we are going to start, so substance X, so the first dot is in line with the dot for B. So this one, B is contained. So B is contained because the line, the dot for X, okay, is in the same line as the dot for B. So B is contained. B is contained. Okay, let's look at A. A, there is no dot also connected, or that is in the same line as X. So here on X there is no dot here, but on A there is a dot. So A is not contained, so not contained. Okay, we now look for C. C, even C, there is a line there and there is no dot under C. So C is also not contained. So we've got two components. We've got A and C. So A and C are not contained in substance X. A and C are not contained in substance X. So A and C are not contained in substance X. So A and C are not contained. So it's A and C. Then we proceed to C. C is saying calculate the RF value for component B. Calculate the RF value for component B. So what is RF value? RF value, R stands for retention. F, factor. So RF value is the retention factor value. And one of the things we should always know about the RF, so RF is written as R and subscript F. So the retention factor, okay, the retention factor is always given by the formula distance moved by the dot or by the spot. So distance moved by spot, okay. So RF is equal to distance moved by spot over distance moved by solvent. Distance moved by solvent. So that is the formula for calculating the RF value. And one of the things that we should take note is that the RF value is always less than 1. The RF value is always less than 1 because in most cases the solvent always travels a longer distance than the solute, okay, which is the spot. So the solvent always moves a longer distance compared to the spot. So the denominator is usually bigger than the numerator. All right, so let's get to work and calculate the RF value, which is the retention value. So we calculate the RF value, which is the retention value. All right, so let's go back so that we extract the data. So we just clear up the whole chromatogram there. We just clear it up so that we can see better. All right, so the distance moved by the solvent, is 28 centimeters. Okay, from where it started to where it has ended. So they're saying the solvent front. So the distance of the solvent front to the distance of the solute front. So B, where is B? B is here. Okay, B is here, and the distance, we've been told that it is 28. Now from 28, we have a difference of 7 centimeters. So what we are looking for is this distance, because this was the distance covered and not the 7. So B moved from the starting point and raised to where it is, which is 7 centimeters below the solvent front. So how do we find this distance? To find the distance moved by B, we are going to say 28 minus 7. So 28 minus 7, this is going to give us 21 centimeters. 21 centimeters. So we have 21 centimeters. All right. So distance moved by the spot B is 21 centimeters, while the distance moved by the solvent is 28 centimeters. We now go to the space provided. Okay. And we are now going to say, so RF is equal to distance moved by spot over distance moved by solvent. So distance, so this will be equal to 21 centimeters over 28 centimeters. So because on the numerator we have centimeters and on the denominator we have centimeters, so the centimeters will actually cancel each other. The centimeters will cancel each other. All right, so we have 21 divided by 28. So 21 divided by 28 is 0.75. 0.75. So this will be equal to 0.75 without units, because the units have actually cancelled out. So 0.75. So 0.75 is our RF value, and that brings us to the end of this question.